All right, today we're going to dive deep inside the human body. We're going to get to know one of the most amazing, most complex networks you can possibly imagine, your immune system.
You know, right now, this very second, there's an invisible war happening inside of you. It's this constant battle against all sorts of invaders, bacteria, viruses, you name it. So who are these defenders? Who's on the front lines of your own personal army? Well, let's meet them.
You know, every good defense starts with a really strong perimeter. So before any battle can even begin, inside, your body has these incredible fortifications on the outside, all designed to keep invaders from ever getting in. These are your first lines of defense.
And this is so cool because it shows two totally different strategies. On one hand, you've got your skin. It's this tough, physical wall that also happens to secrete this antimicrobial stuff called sebum. But on the other hand, you have the moist mucous membranes, like inside your nose. These things use mucus to trap particles. And then these tiny little hairs called cilia literally sweep the bad guys out. And if all else fails, well, you've got a pretty powerful backup plan, the good old cough reflex.
But okay, what happens when a bad guy does get past those walls? Well, that's when the internal army gets the call. But where does this massive army even come from? Turns out, every single defender, every soldier, starts its life in one central location, the bone marrow.
And at the heart of this whole factory is the stem cell. I want you to think of it like the ultimate recruit. It's a biological blank slate. It's a master cell that hasn't been given a job yet, which means it has the potential to become any kind of immune soldier. And these soldiers, as a group, are called leukocytes. Every defender we're about to meet started out as one of these.
And the production power here is just staggering. It all starts with one single stem cell. That cell divides, then those new cells multiply over and over and over again. And here's the key takeaway. From just one master cell, your body can generate a massive army of thousands of specialized immune cells all ready to go.
Okay, so the army is built and it's ready. An invader finally breaks through. Who are the first ones on the scene? That would be the innate immune system. This is your rapid response team. They aren't picky. They don't care what the invader is, they just know it doesn't belong there, and they attack.
And the absolute star player of this rapid response team is the neutrophil. These guys are the most common type of white blood cell, and they are true foot soldiers, just constantly patrolling your bloodstream waiting for the signal that there's trouble.
And this part is just incredible. It's like something out of an action movie. When an infection is detected, the neutrophil first sticks to the blood vessel wall. Then, and get this, it literally squeezes itself through the wall of the blood vessel to get out into the infected tissue. Once it's out, it follows this chemical trail like a bloodhound straight to the bacteria. And when it finds them, it just engulfs them, eats them whole. A true search and destroy mission.
Now, another key first responder is the macrophage. Its name literally means big eater, and yeah, it definitely does that. But it's also a critical communications officer. See, it releases this powerful signal called tumor necrosis factor, or TNF. That signal is actually what causes some of those classic signs of being sick, like a fever or not feeling hungry. But crucially, TNF also sends a message all the way back to headquarters, telling the bone marrow, hey, we've got a situation. We need reinforcements. Start making more soldiers.
So the innate system is great for that initial messy cleanup. But for the really tough, really dangerous enemies, the body has to call in the specialists. This is the adaptive immune system. Think of them as your highly trained elite special forces.
And this chart lays it out perfectly. The innate system is super fast, but it's general. It attacks anything that looks foreign. The adaptive system, on the other hand, is a bit slower to get going, but it is incredibly specific. It's designed to hunt down one particular enemy. And here's the absolute game changer. It has memory. Once it fights something, it remembers it, which means the next time you're exposed, the response is way faster and way stronger.
So let's follow one of these elite soldiers, the T cell. It's born in the bone marrow, just like the others, but then it gets shipped off to boot camp in an organ called the thymus. That's actually why it's called a T cell, T for thymus. And it's here that it goes through this intense training, developing a unique receptor that can recognize one and only one specific enemy. Once it graduates, it gets deployed to the lymph nodes, where it just waits to be called up.
And when that T cell finally finds the one enemy it was trained to fight, that's when things get exponential. It gets activated and starts something called clonal expansion, which is really just a fancy way of saying it hits the copy button. over and over and over. That one single cell rapidly makes thousands of identical clones, all with the exact same target. It's an unbelievably efficient way to build a specialized army on the fly.
So one type of these clones is the cytotoxic T cell, and its job is to find your own cells that have been hijacked by an enemy, like a virus. It patrols your body, scanning cells, and when it finds one that's been infected, it knows the enemy is hiding inside. But it doesn't attack the virus directly. No, it's way smarter than that. It latches onto the infected cell and orders it to self-destruct, destroying the enemy's hiding place from the inside out.
Now let's talk about the other branch of the adaptive system. This one uses special weapons, antibodies. These are tiny Y-shaped proteins. I want you to think of them as perfectly programmed guided missiles, each one designed to lock onto one specific target.
So what exactly do these guided missiles do? Well, first they hunt down their target in your blood. Then they bind to it, which can sometimes neutralize the threat all by itself. But, and this is so clever, that binding process also acts like a big, bright flag. It's called opsonization, and it basically paints a giant target on the bad guy, making it way easier for those big eater macrophages to spot it and come gobble it up.
You know, fighting a war always leaves behind some damage. So after the invaders are cleared out, the immune system has one more really important job. It has to manage repairs. It's time to call in the damage control and construction crew.
Now, when you get a cut, the first priority is to plug that hole fast. And that job belongs to platelets. Just look at the production power here. Platelets are actually tiny little fragments that break off from these absolutely enormous cells in the bone marrow called megakaryocytes. And a single one of those giant cells can produce up to 3,000 platelets. It's wild.
And here's how they work. The second a blood vessel gets injured, platelets swarm the scene. They get super sticky and form a temporary plug. But that's just step one. Next, these protein strands called fibrin form a kind of net over that plug, trapping more cells and reinforcing everything. And the end result is a strong, stable clot that seals the wound so the real healing can begin.
So, when you put it all together, you have the fortress walls of your skin, the first responding foot soldiers, the elite special forces, the guided missiles, and finally, the repair crew. Your immune system is this beautifully complex and coordinated army working silently 24/7 just to keep you alive.
When you really stop and think about the whole thing, the memory, the communication, the precision targeting, it's just mind-boggling. So as this silent army protects you right now, in this very moment, what part of its incredible strategy do you find the most amazing? Thanks for tuning in.